All right, guys. So the tail end of the last video, I know, caused some confusion. We're going to clear up as much of that confusion as possible. All right? All right. So the goal today is you are going to evaluate functions. Okay? So you're going to find cosine of something, tangent of something, sine of something. So you're actually evaluating those trig functions. And you're also going to evaluate those inverse trig functions, like what is inverse sine of a value, for example. But the key is to compose functions, which I touched on at the end of that last video. So just a reminder, composition of functions. So we're basically doing this. We're plugging a number in for x, and we're going to evaluate it for the g function. You're going to find g of x, find that value, and then you're going to take that value and plug it into the f function. So we're literally evaluating two functions today. You're going to find the value of g at x, and you're going to find the value of f at g of x. So the nice thing is that you're doing a whole lot of unit circle practice. But let me be clear, just so that you don't do the first three, watch a couple examples and go, oh, I got it. There are going to be 6 examples in this video. The first 3 are unit circle problems. The last 3 have nothing to do with the unit circle. We're going back to old stuff. And the beauty of today's lesson is literally nothing we do today is new. We are going to drill and kill the unit circle, which my hope is you really know the unit circle. That's 1. 2, we're going to drill and kill the domain and range of the inverse functions. My hope is after the last video that you know where sine inverse, cosine inverse, and tangent inverse live. We're going to drill and kill that. That's old stuff. Whether or not we've, mastered that or not, we'll practice. And then, I know you guys remember back when I made a big deal about drawing triangles and theta and where theta lives, and theta doesn't always live in the triangle. Those problems. The last 3 examples are going to go back to that. That's where delta math kind of set you up and led you astray. So I need to be clear. You're going to do a lot of work by hand, not a lot of delta math for the next 3 weeks or next 3 lessons. So you're going to be doing a lot of handwritten work and showing a lot of work. In the next quiz, we'll say at the top, bold and clear, no work, no credit. You cannot just write number 1, answers 2/5. No, you're going to have to draw diagrams. You're going to have to label those diagrams. You're going to have to prove that your answer is what it is. So make sure you watch this video. This video is very procedural. There are concepts, of course, that you have to know, but it's very much every problem has the same process. So it's very process-oriented with a lot of background knowledge. All right, so if I'm teaching you something and I'm like, you guys remember this, and you're like, I don't remember that, go back and kind of brush up. All right, here we go. We're going to blast through 6 examples. The first 3 are, in essence, the same problem. We'll do multiple. We'll do 3 to kind of knock the dust off. The last 3 are, in essence, the same problem, but it's a different process, and it's an older process, and it's a problem that we've done before. So the beauty is nothing new today, but we're combining a lot of stuff. So it's going to seem like a lot, but nothing new. All right, here we go with example 1. So we are composing functions. So just to be clear, that means we are finding cosine of, those brackets, of sine, of the inverse of sine, of root 2 over 2. So I just want to make this clear that when you see cosine bracket, inverse sine, root 2 over 2, that's what that means. This means we're going to find what happens when we plug in root 2 over 2 into the sine inverse function. We evaluate that value, find that answer, and then find cosine of that. So the first problem in this composition is, what is the inverse sine of root 2 over 2? All right, so in our last video, we saw that sine inverse lives between pi over 2 and negative pi over 2. So this is, in essence, so I'm going to teach as if you've never seen sine inverse. Sine inverse of root 2 over 2 equals what? Means sine of what angle equals root 2 over 2. Okay? And the beauty, and I said this in the video, the beauty of sine inverse is if the input is positive, remember, that's my y-coordinate on the unit circle. So if my y-coordinate is positive, then my angle is positive, and we'll be in the first quadrant. So let me put that there. First quadrant. But if my y-coordinate is negative, that means the angle has to be in the fourth quadrant, and the angle has to be a negative value. Okay? So when you see sine inverse of root 2 over 2, that means my y-coordinate is root 2 over 2 on the unit circle. And what's the angle? Well, my hope is, don't break my heart, is that you know when the y-coordinate is root 2 over 2, the angle is pi over 4 in the first quadrant. So pi over 4, pi over 4. So sine inverse of root 2 over 2 is pi over 4. So we have now found sine inverse of root 2 over 2, which is pi over 4, and cosine of pi over 4 is also root 2 over 2. Final answer. Now, just to be clear, when you evaluate sine inverse and then evaluate cosine, in general, you don't wind up with what you started with, okay? But in this case, the y-coordinate root 2 over 2 and the x-coordinate root 2 over 2 just happen to go together, okay? So that's example 1. My hope is you're like, okay, or you're like, I don't know what just happened. That's why we have example 2. Okay, so example 2 is tangent of cosine inverse of negative root 3 over 2. So the first thing we have to do is find cosine inverse of negative root 3 over 2. So over here, right, cosine inverse, remember, lives between 0 and pi. The output lives between 0 and pi. So we're thinking cosine inverse of negative root 3 over 2 equals what angle? Okay, I'm going to call that theta just to kind of get you thinking angle, right? So cosine of theta equals negative root 3 over 2. All right, well, the beauty of this is if cosine inverse has a negative value, that means that you're in the second quadrant. That means my x-coordinate is negative. So I need theta, I'm going to draw theta in the second quadrant. Okay. Now we already know if the x-coordinate is negative root 3 over 2 on the unit circle, then I already know that angle is 5 pi over 6, which means I know that theta must be 5 pi over 6 if the x-coordinate is going to be negative root 3 over 2 in the second quadrant. So cosine inverse of negative root 3 over 2 is 5 pi over 6. Okay? Now, tangent, just to remind you, tangent is y over x. So I know the x-coordinate's negative root 3 over 2. Well, that means the y-coordinate is 1/2. So tangent at 5 pi over 6 is 1/2 over negative root 3 over 2. And I will not do that work only because we've done it a lot. It becomes 1 over negative root 3, which becomes negative root 3 over 3. 100% unit circle problem. Cosine inverse of some x-coordinate gives me an angle. That angle is 5 pi over 6. And then I evaluate tangent at 5 pi over 6, and I get negative root 3 over 3. 2 steps. Find the value of the inverse function, then plug that number in and find the value of the other function, in this case tangent. Let's do one more of these. So now, this goes back to the last video when you left going, what? Which I would too the first time I saw that. All right, Sine inverse and sine, if these two functions were truly inverses, then if you start with 5 pi over 4, then the output would be 5 pi over 4. But we know that sine inverse is not really the inverse of the sine function. It's like inverse light. It's the inverse of just that tiny little portion of the sine function that lives between, once again, negative pi over 2 and pi over 2. Well, 5 pi over 4 doesn't live between negative pi over 2 and pi over 2. So it doesn't make sense that the output would just be 5 pi over 4. Now, the beauty of all that I just said is you don't have to know anything I just said to work this problem. So we're just going to work the problem and see what happens, okay? I know that the answer is not going to be 5 pi over 4, but you don't have to know that. You can just start working the problem and see what you get. Okay, so sine of 5 pi over 4. So we're starting with not the inverse function. So let me erase this. We're starting with sine of 5 pi over 4, which is just a regular old unit circle problem. All right, so 5 pi over 4 is my reference of 45 degrees. I know that my coordinates are negative root 2 over 2 and negative root 2 over 2 at the angle 5 pi over 4. And sine of that is going to be my y coordinate. So this is now sine inverse of negative root 2 over 2. Okay, now we're in the third quadrant for 5 pi over 4. But see, if I'm evaluating sine inverse, let me make it green. If I'm evaluating sine inverse, I'm no longer in, I can't be in the third quadrant. Sine inverse lives between pi over 2 and negative pi over 2. So the output has to be some angle here. Well, if my y value is negative root 2 over 2, so if my y value is negative root 2 over 2, that means the angle, and this is where it kind of gets tricky, is not pi over 4, but negative pi over 4. Final answer. So I'm going to say what I started off with. If sine inverse and sine were genuine inverse functions, then the output would just be 5 pi over 4. But it's not, because 5 pi over 4 is not in the range of sine inverse. Okay? Once again, you don't have to know that shortcut. But, so when I say shortcut, here's what I do know. And this is what I touched on briefly in my last video. If I put an angle in here, that's any one of these angles. So let's say it could even be pi over 5, which I don't even know what pi over 5 looks like, but I know that pi over 5 is smaller, is between these two angles. Then these will undo each other, and my answer will simply be pi over 5. That's the beauty. Now, if this is 7 pi over 5, I have no idea, right? I would have to do some work, okay? But since, once again, since 5 pi over 4 is not in the range, I have to actually work this out, okay? So this is a shortcut that only works within the given range. There's no shortcut here. There are patterns, of course, but the answer is not simply the value I started with. Okay, so we have done, let's go back, root 2 over 2, I'm thinking unit circle. That's a unit circle problem. Example 2, negative root 3 over 2. That's a unit circle problem. Example 3, 5 pi over 4, sine of that's on the unit circle. So the first three examples were straight evaluating trig functions and evaluating inverse functions somewhere on the unit circle, so it's like a two-step process. We're about to see that that's about to change. All right, so now, and I'm going to ask the question, well, what happens when the values that you're dealing with are not on the unit circle? When I see negative 1 over 3, there's nothing about the unit circle built into this problem. I don't know what negative 1 over 3, I've never seen that as an angle. And I've never seen that as a coordinate, either an x coordinate or a y coordinate. So now is where you're going to have to actually build a diagram, label theta carefully, label x, y, and r carefully, and then use x, y, r, and theta to actually evaluate the problem. So here's what I mean by all of that. So here's an inverse function. So here's what we have. Sine inverse of -1/3 equals, I don't know, I'm going to call it theta, because remember, we're thinking backwards. So here's what we're kind of thinking. Sine of some angle equals -1/3. Remember, this is kind of our thought process, just like in our last video. You don't have to write that, but to me it helps kind of make sense of the problem. So here's what I'm looking at. It's been a minute, but we know that sine, by definition, is the y value over the r value. Yeah, we're going back to x, y, and r. Okay, so that's one skill from the past. But I also know that sine inverse lives between -pi/2 and pi/2. Now, here's crucial. This is crucial. Theta is going to be between here and here. Now, because we're talking about sine inverse of a negative value, that means the y value is -1, which means I'm going to go down one space. Now, this goes back to those diagrams. And I gave you guys a lot of feedback over and over and over. Don't forget theta lives here. Don't forget theta lives there. And I know during those presentations it was awkward, but it happens. So you can label one of two ways. You can label down one, and you can label the actual the position on the y-axis. Or, okay, so watch this. Theta is in the fourth quadrant, so I'm going to draw theta. Theta actually is a negative angle, so theta is actually in the triangle. That's one of those rare occasions where you're not going all the way around to the fourth quadrant, because sine inverse lives negative into the fourth quadrant. Now, I'm going to build a triangle. So my y value is 1, right? So that's my -1. And my r value is 3, so I'm going to draw my radius as 3. So there's my triangle. The height is 1. Now here's where a lot of mistakes happened. You can either say the length of the side is 1, or you can label the y-axis at -1. Is the y value negative? Yes. Is the side length of the triangle negative? No. Delta Math lied to you. Don't listen to Delta Math. Okay, so in every one of these problems, I'm going to indirectly, in the very first process, in the very first function, I'm going to indirectly give you two of these three values. For x, y, and r, you'll be handed indirectly two of them, and then you have to use the Pythagorean theorem. So the Pythagorean theorem, and this is a pet peeve of mine. Pythagorean. Pythagoras was the person's name. The followers were called Pythagoreans, with an N, not an M. All right, so I know x is, I don't know. Y is -1, so -1 squared. 3 is r. -1 squared is positive. Be careful. That's where a lot of mistakes happen. So -1 times -1, +1. Subtract 1 from both sides. X squared equals 8. And then you take the square root of both sides. So x equals plus or minus the square root of 8. Now, once again, sine inverse lives in the first or fourth quadrant. So no matter what the x value from here to here, let me make it green, from here to here is my x value, but I can't leave it as the square root of 8. I have to simplify that, so 4 to root 2. So this is 2 root 2, x is 2 root 2 positive. Okay, so if you're given sine inverse, you are indirectly given y and r. You have to find x. So now watch this. Here's the trick. If there's anything new in this lesson, here's what's new. We called sine inverse of whatever, the ratio could be any number that's between -1 and 1. We called sine inverse of -1/3, we called it theta. So here's where we make this substitution. So cosine of theta. That's what we're trying to find. You can even put it in brackets if you want to make it clear. You're substituting sine inverse of -1/3 for theta. Well, what is cosine of theta? Cosine of theta, by definition, is x over r. Well, we already know x and r. So the answer is literally 2 root 2 over 3. Final answer. Okay, so in this problem, nothing to do with the unit circle, everything to do with kind of building a right triangle, using the sufficient information, y and r, and the fact that theta is in the fourth quadrant, negative. That's what this tells me. Theta is negative and in the fourth quadrant. To find x, and if I know x, then I can find cosine of theta. It's a lot. A lot of background information. All right, let's do another one. All right, tangent of something. So I'm going to call that something cosine inverse of, and it just happens to be -1/3 again. It could be whatever. We'll mix it up in a minute. All right, so I'm going to call this theta. Now this was intentional. This was intentional. Our last example was sine inverse, which lives in the first or fourth quadrant. This example is cosine inverse. Now cosine inverse lives in the first or fourth quadrant. Now once again, just if you look at example 4, go back and look at example 4. We never found the value of theta. We just know where theta lives. That's really all that matters in this problem. So in this problem, cosine inverse, which means kind of thinking backwards, cosine of some angle equals -1/3. So if cosine is negative, then I'm to the left, right? X is negative. So if I have to be in the first or the second quadrant, theta has to be in the second quadrant. So let's write this out. X, Y, R. When I know cosine theta is -1/3, I know that the x-coordinate is -1. Remember, cosine of theta, by definition, is that. Oh, x over r. Whew, help me. X over r. So x is -1, r is 3, similar to our last problem. So I can label -1 there. Open this up, 3. Draw a triangle. Remember, always connect the triangle never to the y-axis. That happened a few times on our last test, like way back. So always, when you find that point, okay, always make sure you connect the triangle to the x-axis, not the y-axis. So I know that my x value is 1. Remember, you can either call the side length 1 or the value on the number line -1. But my r value is 3. All right. I'm not going to do the Pythagorean theorem again, but if I did, I have the same values. I would get that y is 2 root 2 again. So 2 root 2. But here's crucial. Here's where you do all this work, you lose a point. Where does theta live? Theta lives in the second quadrant. So here's where the mistakes happened. Someone's going to put theta here like Delta Math did. That's the reference angle. So theta lives, let me draw your attention to it. See who's watching the videos. Y'all don't break my heart. Y'all better watch these videos. All right, so theta lives there. Once again, I don't know what theta is. I don't know if theta is 110 degrees. I don't know if theta is 7 pi over 9, whatever. I just know that theta is in standard position. It starts on the x-axis, and then I open it up until I hit the radius. Boom, and I put an arrow. That's how you draw theta. Okay. It lives in the second quadrant. Now, once again, like the last example, cosine inverse of -1/3, I called it theta. So now, that's the question. What is tangent of theta? Well, given theta here, and I know x, y, and r, tangent, by definition, is y over x. And I know y over x. So my y value is 2√2. My x value is -1, so my final answer is -2√2. Bow. Final answer. But you have to do all this minutia first. Okay, so really what's new is the last video says cosine inverse of something equals an angle. I have to be in the second quadrant, so that's our last video. And then everything starting here, everything in that red piece of toast or whatever, that shoe, whatever you want to call it, everything inside this red region is old stuff. That's from 2-3 months ago. Okay. And then you come back to what's new, composing. You make that substitution. So that kind of is new. That's our one piece of new stuff. Call it theta. Well, now using this diagram that you just built, using this diagram, what is tangent of theta? Well, you have everything you need. Okay? So that inverse stuff comes into play. All right, let's do one more example. Bring it home. Here it is. Find secant, which we haven't seen yet, but that's all right. Secant of tangent inverse of 3/5. So, tangent inverse of 3/5. I have no idea what that is. Now, if that had been tangent inverse of √3, that's a unit circle problem. That's a completely different process, but I don't know what tangent inverse of 3/5 is. Now, I'm thinking tangent of what angle gives me 3/5. So here's what I know. Tangent inverse lives between -π/2 and π/2. I don't know what theta is, but I know that it's between -π/2 and π/2. But I also know that this value is positive, so I have to be in the first quadrant. Remember, tangent is only positive in the first or the third quadrant. The third quadrant doesn't come into play with the inverse function. So the inverse function narrows down the 4 quadrants to 2, and then the fact that tangent is positive tells me I'm in the first quadrant. So here's what I know. I know x and y. Tangent of theta is 3/5, just to remind you. Rise over run, that's what tangent is. Tangent is the slope. Big deal in calculus. You'll get to that soon enough. So my y value is 3. 1, 2, 3. My x value is 5. 1, 2, 3, 4, 5. 5, 3. Boom. Draw a triangle. Okay, so my x value is 5, positive. It's a length. The height of my triangle is 3, and I need to find y. Is 3, x is 5. I need to find r, so we have Pythagorean theorem. 5 squared plus 3 squared equals r squared. 25 plus 9, 34. There are always 2 square roots. Always 2, but it's a radius. It's got to be positive. I'm going to label it root 34. Now here, once again, you've got to label theta. Now theta is in the first quadrant, so the only time, not the only time, let me take that back. The vast majority of the time when you label theta, it's not inside the triangle. Case in point, example 5. Theta was in the second quadrant, not here. That's the reference angle. So just to be clear, If you're in the first quadrant, you can squeeze theta in there. Otherwise, you just need to be careful. Okay, so we have x, we have y. Those were given indirectly. We know theta's in the first quadrant, not the third, because tangent inverse only lives in the first or fourth quadrant. So now we're trying to find secant of theta. We called it theta once again. Now, let me recap. Cosine of theta is x over r. Secant, therefore, is r over x. No matter what we're doing with secant, we always go back to cosine, whether we're graphing, whether we're evaluating, whatever. So I know the r value. The r value is root 34. The x value is 5. Final answer. All right, so the goal is to compose two functions, one of which is a trig function, one of which is an inverse function, and then you're actually evaluating. So you're finding the answer. For the first three, root 2 over 2, unit circle. Negative root 3 over 2, unit circle. So the problems will be kind of scrambled. 5 pi over 4, that's unit circle. And then you have some ratio that has nothing to do with the unit circle. So the problems are going to all look the same, and you've got to differentiate right out of the gate. Is it a unit circle problem, or is it a I got to show a whole lot of work problem? Either way, you're showing work, and I just want to remind you, practice showing work, because no work, no credit moving forward. A lot of broken hearts. Not a lot. A couple students. Every year, a couple students, 1 or 2 students in every class who were like, I ain't showing work. Got to show work. I don't care. Yeah, you do. You care about your grade. Okay. Work hard, guys. You got this. Hope you watch this video. Work those problems. Be ready on Thursday and Friday to present with conviction. None of this, I do not understand. You better understand it. All right, so if you don't understand it, shoot me an email. We'll work through the problem. I'll make sure that you're ready to present. You are presenting significantly more than just an answer. So for these problems, look at all this work, scribble, 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 scribble. So make sure your presentations include where these numbers came from on the unit circle, not just answer, answer, answer. So your work should look not just like this, but something going on in the margin. So be ready to fully explain where things come from. No, I don't know, and certainly no, I just put it in Desmos. Don't you break my heart and say that. Don't break my heart. So be ready to explain, be safe, and enjoy the rest of your day.